Greetings, welcome to this new video about Supermesh analysis. Solve the problem number 7. Let's consider this network consisting of 6 resistors labeled R1 through R6 as well as 3 current sources IA, IB and IC. The question now is to calculate the mesh currents. Let's move on to the solution. First, let's begin by defining the number of meshes in this network. It's evident that there are 6 meshes. This is mesh number 1, mesh number 2, mesh number 3, mesh number 4, mesh number 5, and mesh number 6. Now let's proceed to assign the mesh currents in this network, and I will consider I1 is the current in mesh 1, I2 is the current in mesh 2, I3 is the current in mesh 3, I4 is the current in mesh 4, I5 is the current in mesh 5, and I6 is the current in mesh 6. After we finish the assignment of the mesh currents, we need to remove the 3 branches containing the current sources IA, IB, and IC. We obtain our 3 supermeshes. This is Supermesh 1, Supermesh 2, and Supermesh 3. Let's start first by applying KVL in Supermesh 1. We can write R1I1 plus R2I2 minus I3 plus R3I2 minus I4 is equal to 0. By replacing the resistors with their numerical values, we obtain 10I1 plus 6I2 minus I3 plus 4I2 minus I4 is equal to 0. If we continue simplifying this equation, we obtain 10I1 plus 10I2 minus 6I3 minus 4I4 is equal to 0. Let's move on now to Supermesh 2. By applying KVL in Supermesh 2, we can write R2 I3 minus I2 plus R4 I3 minus I5 plus R5 I4 minus I5 plus R3 I4 minus I2 is equal to 0. If we replace the resistors with their numerical values, we obtain 6I3 minus I2 plus 3I3 minus I5 plus 2I4 minus I5 plus 4I4 minus I2 is equal to 0. If we continue simplifying this equation, we obtain finally 9I3 minus 10I2 minus 5I5 plus 6I4 is equal to 0. Let's move on now to the last supermesh. By applying KVL in Supermesh 3, we can write R4I5 minus I3 plus R6I6 plus R5 I5 minus I4 is equal to 0. If we replace the resistors with their numerical values, we obtain 3I5 minus I3 plus 2I6 plus 2I5 minus I4 is equal to 0. If we continue simplifying this equation, we obtain finally 5I5 minus 3I3 plus 2I6 minus 2I4 is equal to 0. We currently have 3 equations with 6 unknowns, which means we require 3 additional equations to solve this problem. In order to get those 3 equations, let's focus on the current source II, IA, IB, and IC. We can write IA is equal to I2 minus I1. That means I2 minus I1 is equal to 2 amps. Let's move on now. In the current source IB, we can write IB is equal to I3 minus I4. That means I3 minus I4 is equal to 5 amps. Let's move on to the last one. We have IC is equal to I6 minus I5. That means I6 minus I5 is equal to 3 amps. After we finish applying supermesh analysis, we obtain 6 equations with 6 unknowns. we still only need to solve those equations in order to find the mesh currents. Since this problem is quite difficult to solve, I created the MATLAB program that makes it easier, which given by this picture. After we run this program in MATLAB, we obtain the values of the current of the mesh currents. This is I1, I2, I3, I4, I5 and I6. After completing the calculation, we conduct the simulation using SPICE simulator to verify our results. Now let's proceed to the SPICE environment. Here is our network drawn in SPICE simulator. This is our current I1, I2, I3, I5 and I6. Let's move on now to analysis. This analysis calculate nodal voltages. We can see here that I1 is equal to negative 555.56 milliamps, is almost the same value we have done by calculation. I2 is 144 amps, is also the same. I3 is 289, is also almost the same. I5 is negative 222.22 milliamps, is also the same. And the last one, I6, is 278 amps, is almost the same. Our results done by calculation is similar to the result we have done by simulation. Alright, thank you for watching this video. If you have any question, do not hesitate to contact me by email or leave a comment under this video and I will answer you as soon as possible. If you like this video, don't forget to subscribe and share. See you next time in another example about super mesh analysis. Take care and bye bye.